Hi everyone, in this video we're going to talk about what we call function notation. So I'm going to start us off with a review question, and the review question says, given the equation y equals 3x plus 9, find the value of y when x is 3. If you want to pause the video, you can try this on your own. So hopefully you substituted in the 3 for x into the equation, and when you use order of operations, you should be multiplying first. So you should end up with 9 plus 9, and then when you add the two 9s together, you should be getting 18. So we get that the y value is going to be 18, and again, we had the x value is 3. Technically, if you wanted to write your answer like an ordered pair, the ordered pair that would go along with this would be 3, 18, again, because 3 was our x value and the y value was 18. So moving forward, when we think about function notation, we're really used to seeing equations like y equals 3x plus 9 with slope-intercept form, but in the future you might see the same equation written as f of x equals 3x plus 9, and we refer to this f of x as function notation. And again, I'm just calling it f of x. If you were to write it out, it kind of looks like this, but that means the same exact thing as the y. And it doesn't always have to be f. So you could see it as g of x, you could see it as h of x, but it essentially just means the same thing. Sometimes it would be considered to be like the name of the function. So way down the road, like if you saw something like c of x, it could be like a cost function. So they might use that to refer to the cost. Or if you saw r of x, it might refer to like revenue function. So those are things that have to do with business. But so we kind of start practicing that now, and then you could see those types of things later on. So if I was to give you a problem like this one, it says evaluate each function at the given value. And I'm asking you in this first problem to find h of negative 1. So basically what that means then is I'm going to need to be looking at my function with the h, so h of x, which is this first one, h of x is equal to 7x minus 1. But then you're going to notice how instead of there being an x here, they put the negative 1 in place of x. So then that means that you need to substitute negative 1 in place of x also. So when I do that, then again, so I know I'm using h of x function, 7x minus 1, but then they're asking me to find h of negative 1. So then I need to substitute negative 1 in place of x, and I do that here, but I also have to do that anywhere that the x comes up in the equation or in the expression here. So then I'm doing 7 times negative 1 minus 1. So again, instead of 7 times x minus 1, now I'm doing 7 times negative 1 minus 1. So we still use order of operations, so I should get negative 7 minus 1, and that comes out to be negative 8. So then I know that h of negative 1 is going to be negative 8. If you wanted to write it as an ordered pair, technically the x is negative 1. You figure that's what we substituted in for x. And then we said that the h of x, that's just like a y value. So technically negative 8 is like a y value. So if you wanted to write this as an ordered pair, it would correspond with negative 1, negative 8. Let's try another one. So this one asks us to find g of 2. Pause the video here and try it on your own. I'm hoping that you guys are getting that g of 2 is 7. So again, they're asking me to find g of 2, so I know I need to use the function that is g of x. G of x is equal to 5x minus 3. So if they're asking me to find g of 2, that means that I need to substitute 2 in for x. So then instead of 5 times x minus 3, now I'm doing 5 times 2 minus 3. So then that should come out to be 10 minus 3, and then that's 7. So technically then this would correspond with the ordered pair 2, 7. In addition to doing just substituting in, they might ask you to do like a simplification or something like that. So for example, if they ask me to find h of x plus g of x, then I'm essentially just taking what those two expressions are equal to and adding them together. So I know that h of x is 7x minus 1, and then I know that g of x is 5x minus 3. So I essentially need to add those two things together. So again, I'm adding together 7x minus 1 plus 5x minus 3. You'll notice I started putting parentheses around them, but I really don't need the parentheses here because if I'm just adding together the two expressions, I don't have to, do anything special. And then I'm just combining like terms like I would normally. So 7x and 5x gives me 12x, and then negative 1 with negative 3 gives me negative 4. And then after that, I can't combine anymore because this one has the x with it. And the negative 4 is just a constant, it does not. So my final answer for h of x plus g of x would just be 12x minus 4. And then the next one that I have for you guys is g of x minus h of x. This one's a tiny bit different. So I'm starting with the g of x, which is the 5x minus 3, and then I'm going to be subtracting 7x minus 1. because h of x. However, when I set this up, hopefully you're noticing that if I'm subtracting something in parentheses, I have to distribute the negative. It's almost like there's a -1 here that I have to distribute to the 7x and to the -1. So the first part stays the same, just 5x minus 3, but then the -1 times 7x would be -7x, and then if I distribute this negative, negative times a negative makes a positive, so it's really like a +1 here. And then I can just combine everything same way that I did in the last one. So 5x with -7x is -2x, and then -3 with a +1 is -2. So when I do the simplification for g of x minus h of x, I should be getting -2x minus 2. And we're just going to do one more problem together in this video. So this one asks us to find g of x plus 2. So this one's similar to what we did with simplifying, with substituting earlier, but it's just a tiny bit different. So instead of substituting in a number, they're asking us to substitute in the expression x plus 2. So into g of x, which was 5x minus 3, I'm going to substitute x plus 2 in place of x. So where I see the x, then I'm going to be substituting in, where I saw the x, then I'm going to be substituting in x plus 2. And again, I would make sure I'm putting it in parentheses, because hopefully when you put it in the parentheses, you realize if you were to do 5 times the quantity of x plus 2 and then minus 3, you'd have to distribute the 5. So 5 times x is 5x, 5 times 2 is 10, and then I still am bringing down my minus 3. So then I have 5x plus 10 minus 3, so that's really just like 5x plus 7. And again, with that one, I know it seems a little bit tricky, but I'm just putting this expression then in place of the variable. Anyway, I hope this video was helpful. Thanks for watching.